Hello everyone, welcome to Code with Laya. Today I am going to explain you the operations of double linked lists. So, what does a node in double linked list represent? It represents three parts. One is data part, one is previous address, and one is next address. Right? So we have three parts in the double linked list. First is previous part. It represents the previous element's address, and the present data part and next address. It represents the next element's address. Right? Now we'll see the operations. So what are the three operations present? Insertion, deletion, and traversal. Okay? So insertion can be done in three ways. What are those? At the beginning, at end, and at a particular position. Right? Now we'll see how to insert elements at the beginning. Right? Now I've considered head part. Since there are no elements, head remains to null. Right? Now my first node is sum 20. It is stored at the location 2100 for suppose. Right? Now the previous part. Are there any elements before 20? No. So you write none. So what is the next part? Is there any element next to 20? No. Then this also becomes null. Right? Okay. Now head always points to my first node. Right? What is the first node address? 2100. So this head will be replaced with 2100. Right? Now we have one more part called as tail pointer. So what does this tail pointer represents? It represents or it points to the last node in the linked list. So what is the last node? This is my first node and this is only my last node. So this points to my last node. So that is 2100. Right? Okay. Is it clear till now? Yes. Now we'll move to the next element. Now I'm trying to add element at beginning. Okay. Now first I've added element at beginning. So my head is pointing to my beginning. Right. Since it is only one node present in the complete list. So my tail also points to the same node. Okay. Now I want to insert one more node, that is 32. So first suppose it is stored at the location of 3000, right? Since this is double linked list, you have to represent two-way traversal, right? Okay. Now, is there any element next to 32? Is there any element? Yes. After 32, 20 is present. Right. What is the address of 20? Sorry, 20 is present. So what is the address of 20? 2100. So what is the next part of 32? It represents 2100. Right. Now, what is the previous of 32? So is there any element before 32? No. Since no elements, so you will write it as null. Okay. Now, head always points to my first node. So what is my first node right now? Since I've added at the beginning, it is added at the head position. So my first node is 32. What is the address of 32? 3000. Okay. Now, is there any other thing I have to change? So, what is 20's address? 2100. Right? What is 20's next address? Null. Since there are no elements after 20. So, what is 20's previous address? Null. That means there should not be elements before 20, no? But there are elements. So, what you will write? So, I will write the 32's address at previous. Right? What is the element before 20? 32. What is 32's address? 3000. Right? So, since I have added element at beginning, so last tail pointer points to my last node. Right? Now this previously first node became now my last node. Okay? Now I'll try to do insertion at end. Okay? So So to insert a 10, first what should I do? I have to see which is the last node. How do I know which is the last node? Right? In the single linked list, how do you know that one particular node is the last node? You have to see data's next part is equal to null, then that is my last node, right? So in the double linked list also, if the data part's next part is null, then it will become my last node, right? Or the easy way to find the last node in double linked list is through the tail node. Tail always points to my last node, right? I can directly take what is there in my tail and I can directly delete that, or I can directly insert after that element, right? So what is my last node right now? Tail node, okay? What is tail containing? 2100. Where is 2100? Over here. So you will add next to 2100. That means next to 20. So my new node is 70. So initially while creating, it becomes null. Okay. After establishing connections, right? My tail points to my last node, right? So what is the address in tail? 7000. Okay. Now, what should I change? What is the next element to 20? It is 70. So what is the address of 70? 7000. So this null is replaced with 7000. Okay. Now, is there any element before 70? Yes. What is that element? 20. So what is the address of 20? 2100. So you will replace this null with 2100. Okay. So now we'll see how to insert at a particular position, right? So this is my first node, this is my second node, and this is my third node. Okay. So I want to insert at between 2 and 3. That means third position. Here I want to insert element. Okay. Now my node to be inserted is 64. Suppose this is stored at the address of 6400. Right. Initially it was null. Since there are no connections established. Right. Now I want to add after 3. I want to add after 2 before 3. That means between 2 and 3. So I have established connections. Okay. Right. Two-way traversal. Again, one more connection. 1, 2. Right. So now after establishing the connection, what is before 64? What is before 64? 20. After connection, 20 is there. What is the address of 20? 2100. Right. Now, after 64, are there any elements? Yes, 70 is there. So, what is the address of 70? 7000. Now, after 64, next address will be 7000. Should I change anything else? Yes, I have to change. So, what is next to 20 right now? It is 64, but it was previously 7,000. Right? I have to change this address to 6400. And one more, 70's previous address is 2100. But now 70's previous address is not 2100. What is before 70 now? 64. So what is 64's address? 6400. Okay. So while you're trying to insert at a particular position, you can either, traverse it from, you have to go to the head. Okay. Now after head, you have to go, what is there in the head? 3000. So where is 3000 over here? What is there in 3032? What is next to 3000? 2100. And where is 2100 over here? Right. And what is the next address of 2100? This one. Next you will go like this. So now we have seen how to insert elements at a particular position, right? Now let's see the second operation. No, let's see the third operation, traversal. Okay, we have known what is traversal in the previous lectures also. What is meant by traversal? Visiting each node, and this process is called as traversal, right? For example, if I asked you what is the third node, how can I see? I can either travel from the head node or from the tail node, and I can find what is the third node, right? So if, for example, if I asked you what is the third node and see it from the head position, what is there in the head? 3000. What is the next address of 3000? 2100. So where is 2100? Over here. So what is the next address of 2100? It's 6400. Okay, 6400 is over here, right? So this is the third element. So in case if I asked you to, particularly find what is the third element from the tail node, right? So now I went to the tail node. What is the address present in the tail node? It is 7000. So where is 7000? Over here. Okay. Now I have to see the third node from tail node, right? So what is the address? What is the previous address of 7000? 6400. So my second node from tail is 64, which has address 6400. And what is the previous address of 6400? 2100. So 2100 over here. So this is my third node from the tail, right? This is what is called as traversal. Okay. Now let's see the deletion operation in double linked list. Deletion also can be done in three ways. That is deletion at beginning, deletion at end, and deletion at a particular position. Okay. Now we'll see how to delete elements from the beginning. Okay. So what is meant by beginning? What is there at the beginning? I have head node. Okay. My head node always points to my first node, right? So what is my head node? 3000. So 3000 is here. This is my first node. Now I want to delete this node. So I've deleted this node, right? I've took away the connections between these things. Okay. So now what is my first node? Head always points to first node, right? So what is the address of first node? 2100, right? So it is 2100. So insert, when you try to delete at beginning, the head points to the deleted node's next node. Okay. So now what is there any element before 20? No, there are no elements. So this 3000 is the previous element, deleted element's address. So this is replaced with null, right? This is how you delete elements at the beginning. Now let's see deletion at a particular position first, right? Now I want to delete element at 1, 2, 3, second position, right? I want to delete this element. Now this element gets deleted, right? Now the connection between these elements gets removed and this thing is deleted, right? So these things are again connected, right? Now what is the next element to 20? It is 70. What is the address of 70? It's 7000. So 7000 is stored over here. Okay. Now 70. Is there any element before 70? Yes, 20 is there. So what is the address of 20? 2100. So in the previous address of 20, I have to write 2100. So this element got deleted. Okay. Right. Now if I asked you to delete an element at end. So what is the end? How do you know the end in double linked list? With the help of tail pointer. You need not traverse from head to tail again. Head to last element. You can directly get the last element with the help of tail. Right? What is the address in tail? 7000. So 7000 is over here. Right? So I want to delete this element. This got deleted. Okay. Now what is the last node? My first node is only the last node again. Right? So this is the last node. Now what is the address of this node? 2100. So the 7000 gets replaced with 2100. So the connections are removed. Right? This is how you perform insertion and deletion operations in the double linked list. I hope you all have understood how to perform the operations on double linked list. And if you like my lectures, please like, share and subscribe to Code with Lion. And also please share them with your friends so that it would be helpful for them also. Thank you.